Hello. Good morning, evening, or X or afternoon. Hope everyone's having a good Wednesday, middle of the week. Physics Engine Part 2, Electric Boogaloo today. Keep on trucking with that. I've got a rough idea of what I want to do, what I want to achieve. Let some people roll in, and then we'll start on that. Checking my stats. Hey Julian. Emery on Twitch. Signets, yes, I'm doing well, thank you. Hope you're also okay. Glad you're here, Jeremy. So far, things looking okay. So, I guess for anyone who wasn't here on Sunday, or has not watched the catch-up, we started integrating a physics engine. We are using Jolt, which is a free open source physics engine that is used in Horizon Forbidden West. So it's reasonably battle tested. We're going to assume it's reasonably efficient, reasonably good. It has at least all the features that I think we're going to need, and quite a few extra that I don't think we're going to need. And we've just been slowly integrating it. They have a Hello World sample, which basically creates a box, a static box, creates a dynamic sphere, and then drops the sphere on the box. And that's what we did. We basically went through all of their setup stuff and kind of started building out our own abstraction around it, because I think Jolt has quite a lot of dials, levers, etc. And we don't necessarily need them all. So we're basically going to do kind of like we do with OpenGL. Like OpenGL has a huge amount of features we don't need, so we're going to build our own abstraction around it, which is just exposes effectively the subset of bits we do need, which kind of makes our lives a little bit easier when building out something actually kind of useful, like a game. Like, let me just bring up some of the code. Hey Queco, glad you're here. So yeah, like all this stuff we're building out, like shape, creating the body, like the rigid bodies, and like the body creation settings, and the emotion. I know it's enum motion, but I always read it as like the emotion type. All this stuff we're going to basically this, you could consider this as an abstraction already, because you just create a physics system and then run it, and you get exactly this, which is a box and a ball. What we're going to slowly do is start teasing some of this out into separate classes, which kind of, again, wrap this and just expose it via our own in-game interface. So we'll have probably like a shape class and a rigid body class, and then the physics system will accept, or actually might even be a factory for those, so you can only create like a rigid body via the physics system. Haven't quite decided yet. Yeah. It's not bad. Life's not bad. It's pretty good at the moment, and I get to spend the evening with you guys writing C++, so it can't be all that bad. I'm gonna press a button here. Okay, fine. That's back. Never mind. Because I'm a real streamer now, I brought a Stream Deck, obviously, and I'm still figuring out how to best use it. And sometimes some of the buttons I create decide they're going to stop working. But here we are. Okay, so that's it. We basically wrote a load of code. I'm not going to... Well, let's just... I guess... just run it first. Kind of showcase where we got to, because it's not exciting at all. Like, the journey was much more important than the destination in the last stream. I think it was a lot more fun writing the code, and the output was a little bit lackluster, as you'll see in a minute. So we've got the game here, which is fine, and then this is the physics system simulation. So this is the position of the ball in 3D space, and as you can see here, it slowly succumbs to a downward force. I don't even think it's gravity. I think we just literally apply a downward force on it, and eventually it rests atop the box and then basically just stays there. But there's no visual representation of that, because eventually all those barrels and stuff, we're going to want to wrap like cylinders around them. We're going to want to create a character controller. We're going to want to be able to interact with it. So yeah, that's basically the plan. But I think today, so before we keep, because I think it's going to be at least a stream of abstraction, right? At least probably one of pulling all this out and starting to expose all the bits we need. But as we kind of got something running, I want to do the debug visualization first. So I had a little, I don't write any code, or I don't commit, I should say, any code off stream, but I do kind of have a little play around with some things and have a think about it. And I have found that there's a debug renderer class, right, which you can implement, and then you can basically slap that into the game, and then this will emit lines and triangles based on like how Jolt wants to like give a visual representation of the data. Basically, it won't do the rendering. It'll basically say, if you want to see my debug layer, here's a load of lines and triangles. The debug renderer, I think, has quite a lot of options, but not too long ago, well, I guess 10 months ago, they added a debug renderer simple, which actually simplifies the API even more. So I think we only really have to implement like a couple, like literally like a couple of methods. Here you go. Look, inherit this class to simplify. Inherit from this class to simplify implementing a debug renderer. Start with this implementation. Draw a line, draw a triangle, draw text 3D. And in fact, we don't need this. We'll just log this. I don't really care about having like labels and stuff at the moment because we have no text rendering. Draw a triangle, we can just do in terms of draw a line. So all we really need to do is draw a line. It will not be efficient, but we don't care about efficiency. We just want to get something visually rendering. So what I think we'll probably do is if it's anything like the bullet one, which I've used before, this, you basically say to the physics engine, hey, can you draw all the debug information now? It will go through its internal representation. It'll have a reference or pointer to this class here, and it'll basically just call like draw line, draw line, draw triangle, draw triangle, draw line, etc., etc. So what we'll do is we will hoover all these up into a vector, and then we will render it ourselves. So we're going to have to adjust the rendering code because the rendering code doesn't really support line rendering at the moment. It's kind of quite heavyweight, like all the vertex information that we have, because it's supporting for like meshes. So we're going to want to simplify that. We're going to need to write some new programs, some new shaders. It's quite a lot to do, but hopefully at the end of this we can draw a bunch of lines, which will be exciting because then hopefully we can kind of visually see what's going on. So that's the plan for today. Hopefully everyone is cool with that. So we're going to need a new class. I'm going to call this debug renderer.h. Running once. This game pretty standard fare to start with. And then let's see. Physics. We have to include jolt.h first. And then I did notice something interesting in this header file. Where is it? If you don't define JPH debug renderer, then this header file will fail to compile. So we basically have to tell Jolt that we're going to be using the debug renderer. I don't know, and this is yet to be seen, I don't know if I need to do this for this, what will effectively be this translation unit, so debug renderer.cpp, or whether I need to do it like as a CMake define so that everyone has access to this. I don't know what the implication of when and where you don't define this is, if that makes sense. So we'll see. We'll see what happens. I suspect there might be a bug somewhere where it's like there's an inconsistency in the system because we've kind of half defined these, but I don't want to be overzealous with the hash defines unless we actually need them. So that's kind of my thought process. And then we want to do hash include Jolt. And we actually had a little bit to talk about the Jolt code last time, and I'll kind of keep talking about it as we go along. It's not me like being like bad mouthing or belittling their code. It's an incredibly complex bit of software, and it's very, you know, on the whole, it seems very well written. And you know, I've not written a AAA physics engine, but there are certain design decisions that I wouldn't have done if I was doing it, and I kind of think they're worth like the discussion around it of like why I like and don't like certain things. That's not to say they're right or wrong, but I think there's something to be learnt by looking at other people's code and trying to figure out like, why did they do things the way they did. So yeah. And then literally it just says like we could probably start just doing this. So class debug renderer public jph debug renderer simple. I've just realized there's some mistake there. That should be simple. Give access to that. Gonna want some publics. Gonna want some privates, and then we can kind of get on with it. So we're also gonna want include. So I guess the question is like what, because we're going to want like just a vector of something for lines. I guess the question is what do we want to store in those lines? I'm using what switches am I using? I'm using the Razor purple clickety-clackety ones. I wouldn't be able to tell you the exact name of them, but they're the ones that came in my Huntsman Mini. I find them very satisfying, but I'm also reluctant to bring it into the office because I think it might annoy people because they are quite loud. I've not tried the Yes. My wife has the Razor greens in her keyboard. I think she's got the Black Widow, and then I've got the Razor purples. They're the only two I've really tried. Yes, I was very when my wife got her Razor greens, I was very jealous because they sounded much better than my Corsair ones. So I then had to go and get a more clickety-clackety one. I don't like the silent ones. I like the tactile kind of. I like the noise. It makes me feel like I'm doing work if it's loud. So we've got mesh data. Sorry, take that back. We've got vertex data. So this is the moment in the graphics card when we upload a model to be rendered or a mesh to be rendered. This is per vertex the data we store on the graphics card: the position, the normal, the tangent, and then the UV, which is X and Y. So I'm thinking what probably easiest in here is as we call these draw, line, whatever methods, is we basically just store the representation straight away that we want to pass to the graphics card, and then when we call like I don't know do the debug draw call, whatever we're going to call it, somewhere in the renderer, we can just upload that straight to the graphics card. This is again why it's going to be potentially inefficient, because each frame we're going to have to freshly upload all that data. It's not like you upload the mesh data once and then all you have to do is modify some matrices to move it around. Like the lines in theory will change. Like the physics engine has no concept of these lines which are transforming. It will be like just here are all the lines you need to draw. So it will be it'll be more like sort of old school OpenGL, like 1.1 sort of immediate mode, like GL draw line or GL line or whatever it was. But it's fine. Like I'm not worried, and neither should you be. I think therefore we're going to want a VS source line data.h. And this is going to largely look like this. You're going to have a color and a vector. We don't need that color anymore. We could ham it into the existing vertex data, but then there's then a lot of duplicated data. Like we don't need a normal and a tangent and a UV, and also this doesn't represent color. And again, we could force that into one of the other ones, but like I think in terms of building out an abstraction, we might as well use the right data type. We could fudge it into this. I think we're already going to have to make enough changes to the rendering side of it that this isn't going to. It makes no difference if we then go and add our own data. What's going on? Right. Okay. So I had caps lock on. That's why. All right. Okay, so we don't need a UV. We need to change this to line. Then we just want a position and then a color. And then we don't need the rest of this. So that's going to be our sort of per vertex, if you will. Well, I suppose it's still a vertex, but we're going to draw it in line mode rather than triangle mode. So it should, rather than giving it 3 vertices and then the algorithm, the painting algorithm comes in and fills all the pixels and calls the fragment shader on each pixel, it will just draw the line, and I think it calls the vertex shader on each pixel between those lines. Only one position. Yes, because we will draw each, because we're effectively drawing vertices, right? So they'll always have to. So we'll just store 2 line datas per line we want to draw, right? And then the graphics card will be like, oh, you've told me, you give me 2. If it was only 1 line, you'd be like, oh, you've given me 2 things, and you've told me to draw them in a line, so I'll draw a line between them. That's my understanding of it. It all explodes in a horrible mess. We'll see what happens. So line data, so X now becomes line data. Okay, so we're kind of getting somewhere. Now I need virtual void draw line JPH is the, I'm just copying from the docs, by the way, I don't just instinctively know this. rvec3 arg in, so sorry, from JPH. I don't know, I'm gonna have to look, I don't know what this like vec3 arg is. I suspect it's a reference because it's not passing this via reference, which you would expect it to do, because there's no reason not to, because it has a color and a color arg. You can see here color, and then down here it has color arg. Color, thank you very much. Put the U in, we put the U in here. Override. rvec. Alright, what is this type? Here's an rvec3. It is a constref. Okay, fine. So they've rather than explicitly, again, this is not. Thanks. For me personally, like, I would be explicit that this is a constref, especially as part of an API you expect people to implement. I just think that is clearer what your intention is and what people are doing. They've just written, it's just less typing to kind of alias all their own type. I am, personal opinion, not a big fan of aliasing types. I'd rather just be explicit with what you need to write. There are, of course, situations where that becomes a lot of typing. So the std span const std byte that we've got probably should be like read-only data span, but it's not, because I've not bothered doing that yet. So interesting. So I've been doing this. Trying the trailing return type, type syntax, and last stream we had an issue where the compiler wouldn't accept this because the type I was implementing didn't do it that way, and I don't know if that was just because we had a load of weird link issue errors. I don't know if that was a symptom of the cause or the symptom of the error we're having, but in the end we kind of ended up reverting it. So I'm going to stick to. And I meant to go and look it up in the standard and I didn't. I don't know if this is actually part of the standard or not, whether you have to match the style to what you're overriding. We could try it again later. Once we've got it compiling, we could go and change one of these and see if it likes it. But there was definitely some issue around that. But yes, I know. The theory is it has to be the same, but I don't understand why, because they are effectively the same thing. I'm just going to appease the Jolt library, and then I'm going to keep the rest of my code, especially all my public APIs, of the new style, because I want to be consistent with that. So it's kind of a concession, I guess, I have to make. it was kind of surprising. I just wasn't expecting that, which is one of the joys of C++. You often get surprised. There's this principle in software engineering called, or there's this concept in software engineering called the principle of least surprise. Like the code you write should do the least surprising thing at any given point, and C++ often violates that. I find JavaScript also violates that quite a lot. The virtual void draw triangle, and this has a JPH rvec3arg v1. One, 2, and 3, and then it has a JPH color arg color, and then it has a JPH ecast shadow, which I'm going to ignore because I'm not worried about shadows. Am I missing some includes here? It's hard to say because so that should what's this? That's why. What? Okay. So as we learned in the last stream, you have to include this header before you include any of the other jolt ones. But if you have, like me, a ClangD rule which sorts all your includes alphabetically, then this will not often be the first. So you have to put a little space in here, which is a little bit annoying, but it is what it is. I don't know where this ecast shadow. So I actually have the in a separate tab here. I have the jolt source code checked out because it's kind of just useful to have a look around at stuff. So was it ecast shadow? I assume it's an enum, so can I do like enum cast shadow? Cast shadow. Where's this? Oh, here, enum class cast shadow. So this is this. Oh, this is in the debug. Oh, so I need the debug renderer as well. That's fine. Have I spelled that wrong? Or... Okay, no. How's the physics engine going? It's going great. We're gonna well, it's not my physics engine, but we're gonna visualize it today, which is exciting. And what exactly am I doing? I'm trying to visualize the physics engine. I guess as a whole, we're trying to write a game from scratch, or as much from scratch as possible, with some concessions. Like I'm not going to write a physics engine, but we've done all the windowing code, the OpenGL function resolution code, the native events code, a whole bunch of stuff we've done from scratch. So we've got our own file format. Yeah, so we're making quite good progress for what I believe is now the 22nd stream. What kind of game? Don't really know yet. It's kind of laying the groundwork first. I think it might. I've got some rough idea of some sort of like puzzle game or something, some sort of simple kind of moving around, like a fixed level, like picking things up, putting things down, maybe kind of thing. Don't really know yet. I haven't thought that far ahead. Just trying to get physics engine to work first. But it's a good question. I just don't know what the answer is. Draw text 3D. Could be Bejeweled. Could be Portal 3. It's impossible to say really until we get there. So position. Interesting. So they've gone for const string view. I would say they've gone for const ref string view, but the whole point of string view is you can just pass it by value because it's only 2 pointers. Or pointer and a size. I can't remember which way. Span is a pointer and a size. I think string view is pointer and a size as well. Regardless, it's cheap to copy. It's cheap to copy, so you don't tend to pass it around by const ref. Can, but there's no need to. APH color arg and float. In fact, actually, as we're going to provide effective and empty implementation of this, we don't need to give these names. I think that's good. So now I'm going to go to the actual meat and potatoes of it. Include debug renderer.h. A little bit worrying it's not found it. Oh, because we've been sidetracked by Jolt's file naming convention, and I've now accidentally copied it. Give me 1 second while I change that. Okay. No dramas there. What is going on? Okay, fine. So now I want debug renderer.cpp, debug renderer.h. Okay, right. Awkward. Yeah, no worries. This is slightly different to what the usual content is. My usual video content, I guess, is reverse engineering, and this is more forward engineering. It's it's different skills will appeal to different people. It's absolutely fine if this is I don't expect this to be for everyone, but I like to do both. So I'd rather focus the videos on the reverse engineering side because I find there's not as many people doing those kind of videos, and then because I'd probably write some code in the evening anyway, it's kind of fun just to kick back and do it live with everyone. But it's all low-level stuff, which I think is actually what I particularly enjoy, is just doing low-level things. Debug renderer. And yeah, string view is a pointer and size. I thought so because there's an optimize. I believe it is slightly more optimal. Oh, sorry, take that back. I believe the compiler can potentially do more optimizations if you store a pointer and a size rather than 2 pointers, because it can't guarantee if you just give it 2 pointers they don't alias, as in like point to the same part of memory, at which point there are certain optimizations it inhibits from doing. I think there's something around functionally a pointer and a pointer and a pointer and a size. You could implement both those as far as I'm aware the same, but I believe a pointer and a size is potentially more allows the compiler to do different optimizations, I believe. No, Zig is on my list along with Rust and Go and Odin. They're all on my list of things to have a play around with. I've just not gotten around to it yet. So yeah, not yet. But I'm interested. I'm always interested in learning new languages. I do need to spend some time with Rust. Like I just feel like I should. Do you know what I mean? Everyone always asks me what my opinion on Rust is, and the answer is always the same. I don't have an opinion because I've not used it yet, and it's not a great answer. And there's only so many times I can say that before people are like, well, why don't you just use it and get an opinion on it? Great question. So, as someone who's never touched OpenGL before, am I doing this from reference while I make this, or is this all from my big old dome? I've used I've never worked in the games industry, but I've used OpenGL quite a lot over sort of like the last 10 years. I'm not an expert in it, but I have some experience with it, so I kind of conceptually know like the runes I need to draw in the sand in order to create the right incantation for OpenGL to not produce a black screen. I have off-screen like various notes and snippets of code I've written before, so it's kind of from my brain, but also kind of via a few references because I can't remember the whole API. ChatGPT is surprisingly good for OpenGL code, I think, especially sort of 3.3 stuff. You can give it. I've given it before, like, hey, here's here's some frame buffer code. Can you please rewrite this to use DSA? And it's like, which is the modern sort of a modern variant or modern extension of OpenGL. It's like, yeah, here it is, and it's normally pretty good. Yeah, it's interesting. It says it's not in the JPH. This could partly just be my terrible tooling. We'll see in a second. So this will just be lines dot pushback. Let's write a little helper function up here because we're going to want to convert these to our internal engine representation. So vector3 and color. So namespace. So we're going to go game vector3 to native, and then we'll take in a JPH vec3 arg v game vec3, and then this will be return v dot, I think it's get x, yeah. I think Bullet also has getters for the XYZ components rather than just making them public and then separate setters. Again, I would argue that if you're writing a getter and a setter and they both just get and set with no other logic, those probably should just be public members. There's very little reason otherwise. Obviously, unless you want to trace the API or set breakpoints on it, at which point, yes, you are doing something more than just getting and setting. To native JPH, was it color arg? I'll call it C, keep it consistent. Game color. And then this will be return C dot. Oh, interesting. So these are public. How strange. Are they not floats? Oh, they uint32. Oh. They're storing their colors as integers. Can I? Is there any way I can get these out as floats? Is supposed to be trivial type? Sure, I would agree with you. Interesting. Okay, fine. What actually is the type? Uint 8T. Have I thought about making the code in Rust instead? Nope, I've not given it a single thought. Because I know very few people truly know C++, but I have a lot of experience with C++, and so I can make a lot more progress on that by doing that. So I suppose actually, what am I doing? What am I doing? Equals return static cast float b over limits over. I'll explain what I'm doing in a second. Stood numeric limits. T. I think that's right. So this here is just a lambda which will take in an integral type. In fact, I guess we'll take well done. There. We'll take in an integral type. And then cast it to a right. Yes, color versus color. Sorry, a few comments coming in. Basically, what I'm trying to do is basically, because I'm guilty knowledge what that type is, I'd rather just convert it to a float. So here's a little lambda which will take a value and then divide it by the largest value of that type, and then that will be the float value between 0 and 1, right? So maybe it doesn't like this. To be honest, I'm not actually that fussed about using a concept for this. No, I want it to be a. Yes, this. Oh, that's a good point. Actually, this should promote it to a float, but let's be explicit. Oh, it's because my tooling doesn't understand this yet. That's why this will. So I probably can use stood integral. This will go away when I actually compile it, and my NeoVim doesn't pick up the compiler flags until you've had one successful compile through. So until you've actually done one, like until the compiler has said yes once, it'll be a little bit it'll be a little bit unhappy. It's just kind of an annoying side effect of my tooling. I think the whole like dead games thing is whatever it is kind of really interesting. So the question is like, should you sign a petition to force game companies to release full source code of old games so people can make them better? It's I just think it's almost impossible to legislate because like what licenses is all that code under and stuff like that. Do you know what I mean? Like just they might not be able to release the source code because they might have some sort of license which prohibits them doing it. That you'd have to effectively change so much of the industry. And I'm not saying it's a bad idea. I think games should be forever playable, or at least open to modification, or at least preservable. I think it's kind of a bit of a wish to just say governments can kind of write a law that just kind of makes it all go away. I do think games should not have online activation, in the sense that you can't play this game anymore. Like, I literally have the physical CD, right, DVD, whatever you want to call it, and you cannot play it because the Microsoft took the whole game is encrypted. Actually, because I was going to do a video on this, and it turns out there's nothing I can do on it. The whole game is AES encrypted on the disk, and then you have to connect to a Microsoft server to get the key, and that server's taken offline. So unless you preserved it before that, like, that is literally unplayable. And I think that is wrong. Now, obviously, you don't really buy physical media anymore, but I think that kind of thing you could prevent about, making it so that the game, you don't put in infrastructure such that you could, by removing that infrastructure, you would prevent people from playing that game, unless it's a live service game. Do you know what I mean? Like, it's very hard. There's lots of nuance to it. Law, I'm not a lawyer, but I understand law is quite complex, by design. So, yeah, that's kind of my thoughts on it. Like, more should be done to prevent companies from locking people out of games, but I don't think I think whatever law would come out would either be a halfway house or incredibly complex to implement. Right, sorry, a few comments coming in. Let me just kind of go through this. Been scared to get into C++ because it seems so daunting. As a person who mostly used Python, do you have any recs for getting into C++? Like, C++, I think C++ seems daunting because a lot of people say it is, but it doesn't necessarily mean it's true. Like, I think if you know Python, you can pick up a lot of C++. You could write a class. You could do if statements and functions, and you could probably get around most of the standard library. The thing with C++ is it kind of has it is deep as well as broad, so you can go all the way down to like atomics and memory orders and sequential consistency and relaxed atomics and all that kind of madness if you want to, but you don't have to, and most people won't. I just think, don't set it up in your mind that it's going to be difficult, because it's not. I just think the thing with C++ is there's just a lot of it, and some of it does go quite deep, so it's kind of easy to fall down a rabbit hole and get a little bit lost with it. And some of the idioms and paradigms are kind of unique to it, and I think there are a few foot guns you got to kind of watch out for, like undefined behavior, which you don't tend to get as much of in other languages, or at least they do a good job of hiding it or defining it. So I think just take a project you can write in Python and then just try writing it in C++. That would be my advice. Like, just have a go at writing it. My go-to ones are a ray tracer and like a TCP like chatbot, server and client, which just sends a message back and forth. Write those. Then kind of the thing I sort of suggest to people is kind of take the time, like, write it, and then take a chance to like reflect on it, come back to it the next day and be like, what did I like? What did I not like? What felt difficult? What felt hard? Compared to your experiences in like another language, and go like, what did I have to Google and what did I not understand? What did I have to ChatGPT? What did I copy and paste? And then if you can, like, throw it away and start again, and then you'll do it again, and then your next one will be even better, and then just keep doing that until you get bored of it, and then go on to another project. And each time, try and learn a lesson and try and think, oh, I could do this a little bit better. And then that's kind of, I mean, in terms of resources, the Tour of C++ by Bjarne, the guy who wrote the language, is pretty good. CPP Reference is a pretty good site with pretty good examples. There's kind of loads of stuff. I wouldn't get too bogged down in it. I've just, like, the best way to learn C++ is probably just to start writing a lot of C++. Sorry, quite a few things coming in. I know Fable 3 was kind of playable for a bit, but it's not. I literally physically own the DVD. I own the physical media, but I cannot play it, which I think is just feels wrong. Do you know what I mean? Like, how can I hold something in my hand but not run it? How long on average does it take me to reverse engineer a game? It's really difficult to say because it depends on the complexity and whether I, finish it or not, which I do get a few comments that some of my videos don't end on a particularly satisfying ending, which I'm trying to be better at. I would say I try and get one video out a month, and at least half that, so at least 2 or 3 weeks is spent reverse engineering, and then it's a week of filming, scripting, filming, editing, doing thumbnails, all the kind of YouTube stuff. So yeah, 2 to 3 weeks of a couple of, a few hours in an evening, roughly. So someone said, great, like C++, the build tools are not great. Like, if you've never had to kind of set up like a compiler and a tool chain like that, yes, it is a bit strange. If you want to learn, right, C++, just go to godbolt.org. This is such an incredible tool for learning, and I use it all the time. You can write code. It's even got a Vim mode, right? Just put that brace on a new line there, and then you can select. It has all these compilers in it. So if you wanted, I don't know, the latest Clang x64 Clang trunk, you can have that. You can put in the flags. Equals like C++23, and then like you can go where is it? Execute the code, right? Right, and then you can, it's a little bit slow, but it's a free tool and it's doing a lot of stuff under the hood, and like the stats are crazy how many people use this, like literally every day, like people just using this every single day, and then it will compile it and run it. And then, so if you want to just write C++ code, this is the best way of doing it. And then if you're really interested, you can inspect all the assembly as well. You don't need to worry about that. There's also a hidden, where is it? There's a hidden IDE, and you can add CMake files, so you can actually build out a whole project, and then you can bring in third-party dependencies as well. It's got loads of them. It's got Boost, it's got gtest, so you can actually build out a whole project in Compiler Explorer, and then when you're done with it, you can just save off the link somewhere and bring it back at a later date. So like, don't let C++'s terrible ecosystem be a barrier to entry. Just use Godbolt. Sorry, yeah, I kind of got away late by chatting, but sometimes it's nice just to kind of chat for a bit. Assuming it's not putting too many people off. If you don't know the compiler flags, just ChatGPT it. Just like what modern flags do I need to build a project with, and then just like copy and paste those in for the particular compiler, because they are different. GCC and Clang's flags are largely compatible. Yeah, I don't really know much about Denuvo, so like I know everyone says it's bad, and it's apparently miserable to reverse engineer. I have no plans to look at it because I just think it will take up too much time, and I don't think I could kind of fit that into like a month's video. So it's probably bad, right? Like DRM is generally bad because people break it, and then what was the point? What a waste of like developer effort. Was it piracy as an issue of availability and convenience, not of money? Like people are going to pirate a game, they're going to pirate it. Sorry, yes. It's probably, I think it's a U8, but again, I just couldn't be bothered, like, why, in case they change it or whatever. It's easy just to, this will just compile down to nothing anyway, so this should just work. Sorry, we've been gassing for a little bit there. So pushback is, we had to native from to native color, and then to, and then draw a triangle is draw line v1 v2 color f1 r2 r3 f1 r3 R1. Oops, hang on. Whoa, what is going on? Right. Okay. So we can just kind of caps lock is on, that's why. Kind of just abuse the primitives we've already got by just drawing 3 lines for triangle. It won't be particularly efficient, but should work. Okay, so now we should be able to just add this to our CMake file. Debug renderer. Apologies if I've not got around to your question. I do try and answer everyone's questions. I guess as a plug, I will always respond to YouTube super chats. But that's kind of, you know, that's if you don't want to or can't, that's absolutely fine. I do try and answer everyone's question. Yeah, so macOS stopped using G++ a while ago and switched to Clang. They actually use Apple Clang, which is a fork of Clang, and they contribute some of their stuff back upstream, but it's actually a slightly different. So on macOS, you don't get... It tends to be slightly behind the main Clang. In fact, I think it even has a separate line on the C++23 adoption page. Compiler support for C++23. Yeah, Apple Clang is separate, and it has a different versioning number as well. And I think they alias G++ to Clang++. So yeah, so Clang. So it tends to be GCC and Clang tend to be pretty much ahead in the language features. So those are the things you need to modify the compiler for. As you can see here, MSVC is lagging a little bit behind. But in terms of library support, MSVC tends to absolutely crush it. It's really it's pretty much implemented everything. I think the only thing they have left to do really is flat buffer, I think, and maybe start lifetime ads, but I think that requires compiler magic. So they're waiting for the compiler team to kind of catch up with them. This comes up a lot as well. A great question from Twitch. Do I plan on doing any more of the Vulkan D2 rendering? I have no plans at the moment. Doing follow-on videos, I've learnt, unfortunately, doesn't tend to get as much traction on YouTube, because you either build it such that you either make the video such that you assume people have watched the previous one, in which case if you haven't, it kind of puts people off, or you have to repeat a lot of stuff you did in the first one, which kind of also then puts off people who have seen it. So I've got no plans to do it. I've got loads of other video ideas, and like I kind of like doing new things, so I might revisit it in the future. It was more of I just wanted to see if it was possible. I might have towed the line with the title on the clickbait, kind of suggesting I had completely done it when I'd not. YouTube is hard. Videos live and die by their title and thumbnail. You kind of have to toe that line a little bit if you want to get anywhere, unfortunately. I do try to not be too clickbaity, but unfortunately sometimes, like, you know, that video still got 300,000 views, so ultimately it did pretty well. What is going on? Why am I not building anything? I've subscribed with Prime. Thank you very much. Much appreciated. What is... Remake this. Spend half my time fighting with the bloody tooling. So I think asynchronous programming is kind of interesting. I think Python and C# have really good async models. Apparently Go does as well. I think just kind of, if you want to learn asynchronous programming, I'd probably say have a go with like the Python or C# stuff. C++ has coroutines, so it can do asynchronous code. C++ coroutines are immensely complex. There's a huge amount of boilerplate you have to do. eCache has not remember JPH. I want to do a video or a live stream on it at some point, because it is once you have, so let me start again. Coroutines in C++ are very complex. There's a lot of boilerplate. You kind of have to do a lot of it yourself. Coroutines, at least the stackless ones that you have in C++, under the hood are a state machine, and C++ in very typical kind of C++ standardization fashion, it's like there's a state machine, there's lots of options you could have, and we don't want to be opinionated on any of them, so we will just give you the machinery to define how you want to do it. So you literally have to kind of define all the various transitions and how things become awaitable and what to do when like co-yield is called and stuff like that, and whether coroutines are hot or cold. Do they start running? Do they start suspended? Do they finish running? Do they when they're finished, do they suspended? There's a whole load of stuff you have to do, but doing that helped me understand async so much better in the languages where it is a lot easier, like C# and Python. Pick a load of sensible defaults and go, there's your async model. But having gone through like the grim way of doing it in C++, I felt I understood those a lot better. So I think that might be fun to do. It's kind of easy, you can build a little TCP server like with coroutines in not a huge amount of code. So that might take, if we want to take a break from this at some point, I might do like a live stream on that. Because I started doing live streams on just like random C++ topics, which really I thought were really interesting. But this has taken up like quite a lot of my time at the moment. What am I doing? There you go. I really like fibers. So fibers are effectively stack full coroutines, as in like they can be resumed from anywhere on the call stack. They are a lot more complicated under the hood. You have to effectively allocate a separate stack and do a whole load of other stuff. I've implemented them myself from scratch in assembly. There is a proposal for stud fibers. Windows obviously has native, not obviously, sorry. Windows has native support for it with their fiber model. I think they're pretty good. I think they solve useful problems. I know a lot of people I think Naughty Dog uses them extensively in their game engine, like really extensively. It lets you do what's it called, like the MN job scheduler, where you have N threads and M jobs, but they are fully balanced across all those threads. So if you have one thread saying, I need to do 5 jobs, and then I'm going to wait for those to be finished, you're effectively removing that thread from being able to do work because it's blocking and waiting for all the other ones. So your remaining threads have to divide up the work. Whereas what you really want to do is basically deschedule yourself and say, I want to use all threads to solve them, and then whoever finishes last does the resumption of the original code. And it's really interesting when I implement this, because you can be like, right, I'm on thread 1, and I need to wait for 10 tasks to be done. And by the time they're done, you actually continue on like thread 4. You can literally, your code will migrate from one thread to the other under the hood. It's quite interesting. Anyway, I am talking a lot this evening. But I guess there's a lot to talk about. If not defined JPH debug. I do detest macros. Okay, so we got that working. So that builds. So coroutines allocate. Yes, coroutines allocate, but you in the promise type object, you can overload new and delete. So you can effectively define a custom allocator for them. So you can integrate that into your own allocation schema. Yeah, I think if you want to do it properly, I say properly, like if you want something that kind of works, then Boost ASIO is probably a good way to go. Right. Hopefully got these. Right, there you go. Right, tooling's updated. And we're kind of back on track now. I guess it's not, I've not explicitly called it out. Okay, so, and then what we'll do is here is we will do hash include log, and then do log info debug text str. So at least we'll log it if we do get it. Might be useful. Yes, Asio can use coroutines. Asio is a pretty impressive bit of kit. I will admit, I am not that well versed in Boost. Like, I kind of have a rough idea of some of the parts, but I know it has a lot of really good stuff in it. Because Boost is often like the proving ground for future standardization things, like for instance, like std optional and std variant, std expected, all kind of had Boost implementations first, and then people were using them and gave feedback, and they were kind of battle tested. Yeah, I know. Well, we'll see. We'll see. I might do one at some point. Christ, what have I been doing? Right. So I think as well, I think we're going to need like a auto clear, right? Because at the end of the frame, I'm going to want to clear out all the line data for the next frame, assuming it works how I think it does, where every frame it just like squirts out a load of lines for you to draw. Okay, so let's see, how do we integrate this into our game, into our code? So what was this called? I want so somewhere is going to be using this debug renderer. Actually, hang on, what am I doing? Samples. Test framework. Come on, who calls this? Does you run impl? Just trying to figure out how you actually drive this. I'm assuming it's something somewhere. Actually, you have to presumably add this to the game at some point. Where's the physics system? Here you go. What's this? Draw properties. Draw bodies, do we think? It takes draw settings and then a pointer to a renderer. Let's do, what was that called? Draw bodies. Draw bodies. Samples app, that's probably what we want. Here we go. Draw physics. If the draw, then we call draw bodies, we pass in the draw body settings and a renderer. That's easy to find. So what is the draw settings when it's at home? SV sample app. Draw settings, body manager draw settings. Draw. Settings. I would. Should I avoid using global namespace variables in C++ and inject everything? I'm trying to process what that question is. Global namespace variables. So presumably you just mean global variables. I mean, the general advice is to avoid global variables because they're kind of hard to track and manage, and then like the state kind of persists across multiple objects. So it's harder to reason about. And by inject, presumably you mean dependency inject. Like I would always argue, like dependency inject the things you need into the object where possible. It's not always possible. Sometimes you do need globals, but I feel like they should be the exception rather than the rule. There you go, body manager. What's this? I just want to know what this draw settings object is. So there's a draw settings. Object in body manager. Okay, fine. There's body manager. Here you go. Right. Oh my goodness, that's a lot of balls. That's a lot of flags. So we've got draw get support function, draw support direction, draw supporting face, draw shape. Oh my goodness. What have they set theirs to? Body draw settings. What? No. I just want to know what their sort of like default initializers. Do they just... This is all UI stuff. I don't care about this. Where do they create this object? I guess we just pick the ones we want. Draw shape color, draw shape wireframe, draw. So there are some defaults. We could probably just default. I guess we just default construct this to see what happens. I mean, what could go wrong? So physics system. What have we been writing? A debug renderer. So this will take. So I will dependency inject this in because I will need to access it out. Well, actually, no. Should the physics body own the renderer? Or is the renderer outside of the responsibility of the physics system? The physics system will ultimately need to decide whether to render it or not. We're going to, in a release build, we will not want to render this. So we could dependency inject in a pointer, and if it's null, it doesn't draw it. That could be fine. Because ultimately, outside the physics system, we need access to this data, right? I mean, I've not even written a accessor for it yet. So do we pass in the object? Yeah, I think you might be right. I think we will keep this separate. This is the debug only for the physics. We'll use it for other draws. No, I'm not using delta time yet. It's just fixed because I'm lazy. We'll go back and add that later. It's on my to-do list, but it doesn't get us where we need to at the moment. Ideally, I want to have a fixed. Well, ideally, the physics system should update at a fixed, predictable rate, like every 1/60th of a second, and then the graphics should just update as fast as possible. But we'll fix a better time loop, game loop later. At the moment, it's just every frame it just advances it 1/60th of a second, which is fine because I have VSync on. So actually, I'm probably kind of getting away with it. Let's pass it in. So let's do debug renderer. And there's no point sticking that in the import because we've just about make unique, isn't it? Here we go. Okay, so let's do debug renderer. Debug renderer. Yes, I've seen the issue. And then debug renderer. Okay, so we'll save that off for use later. So then in the update, we will update the physics, and then at the so let's get rid of this logging. I'm hoping it's going to go away soon. So this just updates it. And then we will do if debug renderer. What did I say we had? We had something like impl physics system dot draw bodies, and that takes an in settings. I'm just gonna debug renderer. This is not optimal. This is going to allocate this struct every time. In fact, actually, let's just not worry about that. Static JPH. What was it called? I've already forgotten the name of it now. It was body settings. This bodies. It was body. Body manager draw settings. One day I'll get good at Vim. Static const auto settings equals body manager draw settings, and then down here, in here, I think it passes as a reference, so I think I can just do settings. There you go. Right, so now it won't allocate it on each frame. It will just allocate it on the first call, and then just have us just be statically allocated. So I guess what we now need to do is go to main. We need to include our debug renderer, and then wherever our physics system is, we'll do auto debug renderer equals game debug renderer, and then we can pass into here a pointer to the debug renderer. And I now have access to this, so actually let's go back to the debug renderer header file. Oh my goodness, lots going on today. And then do span, and then we'll do auto lines const span const line data. All right, and then go to our implementation file. Ooh. Our implementation file, and then we should be able to just slap that in there. Debug renderer, and then just do return lines. Okay, cool. Right. Good question. How am I getting GPU acceleration WSL? I'm not. I'm cross-compiling for Windows, so the actual thing we produce out is a Windows executable, and then when you launch a Windows executable from WSL, magic happens and it just launches it natively in Windows, but keeps the std out instead of connected, so you can still monitor it in your terminal. So that's kind of how. I'm not doing anything like any magic other than that. Yes, this is the reason I did it. What you want. If you want to go down this rabbit hole that I've gone down, is this, the MSVC wine project. This is what I have set up. So this allows you to run MSVC like the native MSVC on Linux and get all the MSVC goodness such that it is on Linux and just produce a Windows executable. The benefit of the training arrow is the benefit is minimal. I just wanted to try it on a decent project to see if I like it, and I actually quite like it. I actually, in terms of cognitive overload, for me, it turns out I actually care about the return type probably least. I'm actually more interested in the name of the function, like the arguments it takes, and then what it returns. So reading left to right, I actually find this slightly more intuitive, but that's just personal preference. That's for each person to decide for themselves. Yeah, cool. You got to work with C-line. That's nice. Like I have tried C-line before. It's pretty good, and I know a lot of people who really like it. You got to find tooling. You got to find tooling that works for you. I've sort of been slowly over many years improving my dev environment and stuff, and trying new things, and I've recently upgraded my shell to Fish because it slightly looks better than Bash, and it's something I want to play around with. But just because it's right for me doesn't mean it's right for everyone else. Yeah, I used to use VS Code with the Vim bindings for ages, but I miss tmux, right? That is the killer feature for me, is in single, very simple keystrokes being able to just create and split and create windows that have an SSH session open some of them, or split it and have two side by side and then create another one and do something. Tmux is pretty much is invaluable for me. I struggle very much to not use tmux, and then kind of everything else is pretty much a second-class citizen after that. So we'll update this, and then what I'm going to do is I'm going to do game log debug lines, and then we're going to do ps dot nope. Oh, we're going to do debug renderer dot lines dot size. I'm just gonna print those out and just check that we are filling it with some data. I don't know what the data is. It could all be rubbish. That's kind of fine. I didn't like that. That strap died. Figure out what this. I think so. What's good about MSVC? I personally prefer the native tooling. I know you can use Clang CL. That's fine. You don't have to use it. I mean, you kind of mentioned you sort of disregarded the one remark I was going to make, which is their standard library implementation tends to be slightly ahead of everyone else. It's always good to compile with multiple compilers anyway, right? So I've just used MSVC for so many years. I don't mind, and the current state of it I think is pretty good, so I don't mind using it. Why'd that crash? Right, let's get up a debugger. It's that time. Okay. Where are we? Okay. Right. Access violation. Sounds like a null pointer dereference to me. Where am I on the call? Oh Christ, where am I? What is all this? Where's my code? Where is my code? Symbols, game, main. If you could just stop on main, that would be great. Am I here? Is this main? This is main, right, okay. Source. Okay, fine, we're here. Let's have a look at where we died. Okay, we've made a window. That's good. Good to know. Why have I've not asked us. Oh, have I switched threads? Because Jolt spins up a bunch of threads. I could very well be in another thread. Nope, I'm resolving the WGL functions. That's fine. I tell you, FN control. Let's go. Pop out here. Get out here. Am I back in main yet? Nope. Okay, fine. I don't really want to be doing any of this shite. Okay. I'm back in main. We're back in business. I suspect the only thing that's changed is this. So let's set a breakpoint here and run to that. Oh, crash before then. Interesting. Well, the only other place... Sorry, you're going to get my half sort of... This is how I debug in my head, is sort of ask myself lots of questions and then question my sanity. So you're kind of getting a raw insight into how I solve these kind of problems. I've not changed a lot of code. It's unlikely to be constructing that. Let's just set a breakpoint here. Restart. Oh, and the debugger crashed. Right, okay, off to a good start. A little bit sad. I do wish there was like a GCC for Windows. I mean, I know there are some, but I guess my assertion should be I wish I knew how to use it. Actually, I don't know. I don't know how a command line debugger would work under WSL for Windows. Now that's an interesting project someone should make. Okay, so source. I'm in main and I want to set a breakpoint here. It runs through. Why is it doing here? I don't understand. Why it's... Oh, it's because it's doing this TLS callback, that's why. Okay, fine, let's just... I don't care about user or system TLS callbacks. Save, restart. Let's try again. Nope, debugger crashed. Exciting. Try that again. Who thought they were going to spend their Wednesday evening watching a debugger crash? Certainly not. Certainly not me. Okay, those remained unchecked. I need to remember to recheck those before I have a project which some software uses TLS to TLS callbacks to try and detect anti-debugging. Okay. We are here, which is exciting. So I suspect this here is the constructor for the debug object. Yep, we can see here. I need to point to the screen then, but that doesn't do you any good. The purple string at the top there, it says debug renderer : debug renderer. So this is the constructor for that. So this will... Oh, there's whoa! So it crashed constructing a debug renderer. So the only reason that could, sorry, I don't want to make two sweeping statements. I suspect the reason, if I can get the bloody renderer up, right. I suspect it's not actually implementing, it's not initializing the base one correctly. I don't think it's my code because I don't even have a constructor, right? I have a default declared one. Sorry, I have a default constructor. What's their sample code say? Where have I gone wrong? It literally just says start with this implementation. It's not like, oh, but then you need to create like a constructor that does something. Because their one implements debug renderer, right? But they don't even have, they just, oh, they do have a constructor. What does their constructor do? Well, that's terrifying. It calls the base initialize, but that's fine because mine should call it. It's not looking great, Harold. It's not looking great. We've created a debug renderer, which implements the JPH debug renderer simple, very much following their guide on the inherit from this class to simplify the implementation of a debug renderer. Start with this implementation, and we sure did start with that. Constructing this object crashes. And we don't know why. That's where we're at. I suspect it's not my constructor crashing because I don't have one, or I have an implicit one. So it's probably something in here, but I don't know if I need to pass in some extra arguments to it. They just have, I can't do because they just have a constructor, an empty constructor, which just calls the base initialize. So we got first chance. Where where is that first chance exception coming from? I think that's the. Ugh. Don't want any of this shit. Right, let's try again. So let's set. I think it's. Did we say this was the Oh no, that's there. Oh, interesting. Okay, so we in their code now. I'm just trying to work out what the hell is going on. That's the window native handle call, which is here. So this is all. That's the debug. I'm very confused now because I feel like I'm in a different place than I was before we actually crashed. Where's the call to debug renderer? Right, okay, I think it's this that's crashing. So let's set a breakpoint here, get rid of whatever this is. Nope. Let's just start again. And debugger crashed. Great. Get a little bit grumpy with this. For anyone just joining, that is not the first time it's crashed. Try again. Right. Oh, is it a bookmark? Okay, fine. Thank you. I've learned something today. So we're now at the front. Toggle bookmark. Good shout. I'm glad someone out there knows what they're talking about. Right. Okay, so here's the call, right? This is the call to the debug renderer constructor. Let's step in Oh, thanks for all the thunks. Stamp in. So my constructor. Oh, I see. Okay, fine. You just watch it. I must have misclicked it. I must have fat fingered it. Well, at least someone's out there to kind of, I don't know, keep me in check. Okay. So this is implicitly created for us by the compiler. I didn't define it, but you can see here it calls the debug renderer simple constructor. So I suspect that's where it's crashing. So step into that. This then calls the debug renderer one, which again I suspect is where the issue is. This calls initialize. No, sorry. This calls the constructor, and then later on we call this. This must be initialize. Yeah. Okay. Fine. This is all quite unoptimized code, which is why there's lots of just like moving stuff to like shifting stuff to registers back and forth. So is it the initialize or is it the constructor? Yeah, we've looked through that. I've not looked at it to initialize yet. I'm just trying to track down where the issue. So the issue's got to be either with the debug renderer call or the initialize call. Okay, so that crashes. So it doesn't like the debug renderer. So let's go look at the source code for that. It's probably something stupid I've done. Oh, I think I know exactly what this is. I think I know exactly what this is. I got all this setup chuff, right? Which needs to be called first. I need to register the allocators and the types and everything. But look, I'm constructing the debug renderer before the physics system, so none of this would have run by the time I get here. So I imagine that massively validates whatever jolts and variants are, which is a little bit annoying because it means the design now gets a little bit messy. I either need to construct it and set it, or the physics system just needs to own it. I think the easiest thing is just to make the physics system own it, and then we can basically toggle it on or off later as we need. I bet that's it. I'm almost convinced that's it. Sometimes you just get divine inspiration. So let's go. Let's make this a unique pointer. Actually, no. Now we'll just shove this into the implementation struct, because we had this problem last stream where I was trying to construct all the stuff in the implementation struct, but I couldn't. But all this had to be called first, which is why we couldn't make unique in the initializer list. We had to defer it to here. That is why. So actually, let's get that back, because what I'll do is do auto debug. It's a little bit grim. We'll just, as like a trapdoor, we'll just expose that out. I don't really like that. We probably should just pass through the APIs in here outwards, but as we're probably going to pass them all through, I can't really see any harm. Like, we're passing the object in, or we pass the object out. At some point, someone needs access to the debug renderer, so I'm not too fussed about that. And then up here, we will have a debug renderer. This is fine because this can be default initialized now when we make unique, so that's fine. And then now in the update, we no longer have to check if it's valid because we're always going to have one again on release build. we'll make it optional. So I want the address of impl that, get rid of that. Did I put the underscore? I did. Damn it. Okay. Okay, hopefully that makes sense, like why that was an issue. Hopefully that makes sense. So now we don't need debug renderer. In fact, that can go, because then down here, rather than doing debug renderer, we can do ps dot debug renderer dot lines dot size. I think. Thoughts, feelings? If you say it with enough confidence, the compiler will just give in and do the right thing. You are not wrong. Interesting. I've not looked at initialize, but obviously if it's doing allocations, then it won't be able to do anything until you've registered the default allocator or whatever. So that kind of makes sense why it's crashing. Unresolved external symbol. Oh yeah, because, and I'll tell you for why. It's an unresolved external symbol because I've only declared it. I've not defined it. No. I've only declared, yes, I've only declared it, I've not defined it. I always get this the wrong way around. Okay. Give that another go. Still got to munge all this into OpenGL at some point. Okay. That is a lot of lines, and I'll tell you why it's a lot of lines, because const auto debug renderer equals ps dot debug renderer ps x, and then do actually no, what am I doing? It's not the responsibility of this code to do this. I actually want to do it in update. Update should at the beginning do import debug renderer dot clear. It's like, okay, new update, clear the data, update the physics, crap out all the lines. Okay, so it's pretty consistent number of lines there. There's a flag you can set in Jolt which basically says use STL or use their own internal like containers. So I don't know if that's got something to do with it. This comes up a lot, and I don't mind answering it because it normally means someone's new to the stream. So welcome, hello. This is just a personal. This is just a style I'm trying out on a medium-sized project to see if I like it. There's no real benefit to it. I kind of like it. I think it reads better. I feel like the information that I care about more is on the left, and because I read left to right, potentially is kind of has lower cognitive overhead. But I don't know. Just trying it out. You don't have to use it. I have talked a lot and not gotten anywhere yet. Okay, fine. So we've got a bunch of lines. So now the next thing to do is to render them. Let's have a look. Let's remind ourselves how the rendering code works, because it's been a while since we've poked our heads through here. So we bind our frame buffer, clear the buffers, we'll clear the bound frame buffer, set up our camera data into a buffer, we bind that buffer to a uniform to a UBO, set up the light data, bind that to an SSBO, disable depth parsing, render the skybox, enable depth masking, depth writing, render out every entity, unbind, clear the default frame buffer, so the screen buffer, or what will be flipped to the screen buffer technically because it's double buffered. Do the post-processing effect, which is the tone mapping and gamma correction. No, I basically once we. I don't think it was crashing in initialize. I think it was crashing in debug renderer constructor. I think it was crashing in here. Yes, this is why. Oh, it was asserting. This is exactly why it was crashing, because I'd not set the S instance, which we do in that initialize code. So this is exactly why it was crashing. But before I actually stepped through this, I realized what the issue was and then went and fixed it. Yeah, I didn't even get to the initialize code precisely because this was prevent. I assume it wouldn't work without this, but yeah, that's a good point. Hey, see. Okay, so I think basically after we've rendered all the entities, we're going to want to do kind of draw all the lines. So I think I don't know how best to integrate this. It's going to be a little bit messy. It's going to not fit into our current rendering pipeline particularly nicely, but it's important that we do it. So I'm not too worried about making some concessions. I already have the debug draw in the it's true, but I don't think that will help us. Because this is all ImGUI specific stuff, I kind of want to keep this. I guess the question is, no, I'll tell you why this won't help, because this deliberately happens after all the other rendering, including the post-processing step. So this renders out the entire frame, and then this slaps the line data on top. I can't do this because I need access to the depth buffer of all the materials. I need to make sure that the lines are drawn within the 3D space, if that makes sense. If I just drew them afterwards, then they would all be drawn, and it would be hard to get any sense of when one thing is behind another. It would look quite messy. So it has to unfortunately be in the renderer, and it has to basically be here. I mean, you could do it before or after here. So there basically has to be some concession here, and then we unbind, we do the post-processing, and then we slap the UI on top. I think Scene should own this, in the sense that it already owns the entities, the lights. It should own the skybox. This needs to move into. It's on my to-do list to move this into Scene. It should probably also own Gamma as well. Potentially also own the camera. Scene is kind of a bit of a dumping ground of everything we want to render. I hope your week's been okay. But yeah, today is Wednesday, and we're doing some C++. So I think something in here needs to have a vector of. It needs to have just a straight up reference to the debug renderer, which I'm not sure I like. Or it needs... It needs the line data, right? And we can basically say that the scene contains a bunch of entities and a bunch of lines that you need to draw and a bunch of lights. I think that seems fair. Obviously, we'll have to have a separate material for the lines, and the renderer can kind of manage that for us to be like, okay, here's a scene, here's how you do all this. Again, if there's no lines, then we just don't have to bind those materials. I'm just trying to think what the line data is, because unlike entity, right, which has a mesh, which has a buffer, this is already backed by GPU memory. So these pointers here are already entities which have their data already allocated on the GPU. We need to basically have a CPU resident memory, and then the renderer, unfortunately, is going to have to be like, right, okay, I'm going to have to upload this to the GPU to you every frame, which is kind of annoying. I'm just trying to think, but it might not be too bad, because we're basically just going to, in one lot, GL sub buffer data, whatever it is, and just like squirt it all into the GPU and then render it. It's going to be okay, I think, and then probably have to deallocate that buffer at the end. Or this owns a buffer as well, which is created once, and it writes all the data to it every frame, because I believe write GL name buffer subdata. I give it an offset as well, so I can be like literally from this, like from 0, here's all the data. In fact, actually then, can you not just use buffer writer? Yes. Okay, because this takes a span of line data, we could literally have... So in fact, sorry, you'll see me live design this. Struct debug lines, right? And this will have a std vector line data. Std vector of line data. Now the question is, do I create a copy of it, or do I create a non-owning reference to it? I feel like there's potential lifetime issues there. We are already on the unhappy path of optimization, of like efficiency anyway. This will mean now, unfortunately, I can't have a default constructor for the scene. Annoyingly, maybe this won't work because buffer has to have an initial size. What happens? Does GL named buffer subdata grow the buffer? That's going to be important here. Here we go. Offset and size must define a range lying entirely within the buffer's object data store. But if you use GL buffer data, this avoids the cost of relocating the data store. So presumably GL buffer data Why would you not be able to use in Gizmo? Because that renders over the top of everything, right? There has no concept of the depth of the scene, and I want the lines to exist in 3D space. If there's a bounding box around something, I should only see the lines that I can see, not effectively all those lines slapped on top of the final image. Creates a new data store for a buffer object. When creating the new storage, any pre-existing data due to the new storage created with the specified size and bytes and usage. Okay, fine. So what we need to do is modify buffer to... So here's what I'm thinking. We could... I feel like we've gotten quite far away from drawing lines now. Now we're down to rewriting the OpenGL buffer class, but here we are. Like, there is no other way around it. We could track the size, as in buffer could own a copy of the size. When you write data, if the data you are requesting is larger than the size, called GL buffer data, update size, otherwise called buffer subdata. Does that break the kind of invariant that we've held so far that buffer is fixed size? In the sense that, would we consider it a bug to write beyond a buffer in any other code, if that makes sense? Like, if I say this buffer has to have 100 bytes in it, and I try and write beyond that, do I want the code to... I mean, this should be doing a bounds check. It's not. That's my fault. Should we bounds check it and throw an exception and say, you've tried to write to more data, or should we just allow that buffer to grow? What I'm saying is, should this be a static buffer on the GPU and we adhere to that, or should we let it be dynamic? Or do we have a flag that controls it? Or do you have another class? Do you have a static buffer and a dynamic buffer? Oh, so many questions. So many questions. I think 10 people just dropped off the stream when I posed this question, so I don't think that interested in the answer. Thoughts? Feelings? Anyone? I'm kind of happy to throw this idea around a bit. We have to assume that when you give it the size, can't combine the line size with everything else. So you suggesting that we just reallocate this buffer every time? So every time we set debug lines, we just allocate a new buffer of the right size, which actually might be a good idea, because then that removes the need for us to change this. We keep the invariant that buffer is static, and we are effectively doing what GL buffer data would do anyway, just with a little bit of extra chuff. So that might actually work. Yes, I agree. I think a distinct difference between dynamic and static buffers would be good. If we were to do that, do you have two separate classes, or do you have some sort of like tag dispatch or boolean or enum or something which basically says dynamic? I think I've answered my own question. I don't like that, because I think I'd rather two separate classes. But actually, so here's a thought. I'm losing people. They're dropping off. They don't care about this. They just want to see pretty colours. Right. So when you create a scene, it will start off with no debug line information. If I want to have debug line information, I can set it, right? So that means in the renderer code itself, it can be like, do I need to draw anything debug? No. Then we just don't do any of this crap. And then, because it's optional, I don't have to worry about the size, doing an initial allocation on it. It's just optional. And then when I create it, I just create a new buffer. I just stick a new debug lines in here, and I just make sure I set the buffer to be the right size, and then use buffer writer. The buffer size is set at the scene render construction. The buffer size will be set when you create this debug lines object, and because it's optional, it'll start off empty, or is empty the right word? Yeah, unset, empty, which you can query for. And then each frame, I basically just replace the optional one here with a new one with the latest line data. In fact, actually, what you could potentially do is check if the number of lines has changed, and if it's not, don't bother updating this, and you kind of just assume that because the lines haven't... Oh no, I suppose they could move. No, that's a bad idea. Scratch that. Don't like that. That's wrong. I think I hate that this the least because it's semantically more obvious that the debug stuff is optional, and it just means that in a release build we just never set it, and I don't have to worry about horrible if-defs and stuff, and that you should pay the cost of one optional check in the render loop, which at the end of the day is pretty marginal. It means I can update, conceptually I can update the debug lines, because I'll be like, here's some new data, please draw it. Yeah, I think I like this I hate this the least, which is often how my sort of like internal monologues go. So now, where we do draw the lines, what we actually do is if scene dot debug lines, so if this exists, right, there's an explicit bool operator, so I can just slap that straight in if statement, then draw all the lines. Yeah, we'll make sure the OpenGL buffer is big enough when we get there, right? So now the question is, what am I rendering? Because the moment I have a mesh, right, which has all this stuff in it, positional. So we're going to have a new mesh. We could, again, we're at a juncture here. Got to think about this. We could have a mesh, another constructor which takes the line data and internally calls all the right gubbins for it, and could actually write the buffer data at the same time, because the because mesh owns a buffer. Oh, maybe this is better actually. Would I need a VAO? Or would I just call draw elements GL lines? The color scheme is Dracula. I need position and color. So I do need two attributes. Basically, I guess the problem is solved by doing this code but in a different format. So the question is, does that live in a mesh class or does that live in a line draw class? I guess ultimately it doesn't matter. I think I will create a new class, because then I can just have the bits I want, and then that can own the VBO. So in fact, actually my optional becomes just this object. Yes, okay, I like this even better, because now I don't have to worry about these two getting out of sync, because I might just make debug lines its own class, which does all this. All right. Let's just copy that. So I don't want this or this. In fact, I don't even know why I'm doing this because I need to get rid of all these. Get rid of all that. I need to bind it, unbind it. I don't need the index count or the index offset. I'm just going to bind it and draw it. So I don't need a VAO. I just need a VBO. Okay, I think that's what I need. And I'll just construct a new one because C++ and RAI. Once I replace this, it will just destruct it and effectively unload that object from the graphics card, or destruct it, call the right GL delete function. Yeah, I will need the color because I plan on drawing them all. I plan on drawing them all in a single call, even though I will be uploading to the. I guess, yeah, it might not be too inefficient. We'll see. You know what? We can but see. So let's get line data, okay, and then let's treat ourselves to a little spam. And then we will have debug lines, std span, const, I can't remember what I called it, line data? Lines, okay. Now we're getting somewhere. Source, debug lines.cpp. I'll be amazed if this just works. Okay, let's get rid of mesh.cpp before I get myself confused. Alright. Okay, let's go through all this. Don't need TLB. Do need line data. Okay. Okay, so don't need the VAO, I think. Do need the VBO. Don't need that, don't need that. The VBO needs to be, I think this just needs to be lines.sizeBytes. Write all the lines in. So this will construct the buffer. This will then write all those in using primitives we built before. People are kind of interested in those. I can go over them. Then, do I need an empty VAO? I don't think I do. I think I need to get rid of all this. Oh no, wait a minute. Oh no, I do need a VAO because I need... Sorry, getting a bit ahead of myself. I don't need an index buffer. That's what I don't need. I do need a VAO. Because otherwise, what else am I binding? Sorry. Because the VAO holds all the attributes. Getting me terminology a bit confused here. Apologies. Just going back in time a bit and resurrecting this line. So we'll create a VAO, we'll create a VBO, we'll set all the VAO stuff, which is, actually I just get rid of this now so we can see what we're doing. So size of line data. Don't need the element buffer. Do need, we'll have to write, we'll write the shader in a second. Do need the 2 there. Don't need that, don't need that. Okay. Normal becomes color. These are 3 floats. Index, bind point, whatever we call it, 0 and 1. Enable those. Enable this. Enable this shit. Bind, unbind. Don't need any of that. Easy. Okay, actually not too bad. Let's just get that compiling. What do I call this? Debug, something or other. Debug lines. 2 hours in, not drawn a line yet. Doing well. Thank you everyone for sticking with me. To experience all the highs and lows together. Apparently my disk space is going to run out in 24 hours, so the stream has a hard cap at 24 hours, I'm afraid. More hours before my disk space fills up. I blame Path of Exile for being like a nearly 100 gig download. Compiling takes long because I think MSVC Wine is a little bit slow. I think my setup is not that great. This is definitely hung. It's not necessarily slow. It's just sometimes it hangs, and then CMake gets confused. It's like I don't know how to build any of this. I appreciate it's not the best for kind of like live viewing, but it's pretty realistic. So if anyone's interested in getting into C++ dev, compile times are interesting. I think someone said I missed something, like a namespace or something. Oh yes, well done. Good spot. Don't need ranges, don't need us. So it's not using make, it's using Ninja, and I believe the default is I think it's number of cores or number of cores -1. I don't actually know what the default is, but it does. I mean, Ninja does parallelize kind of out the box and makes the most of whatever how many cores you've got. 20 cores. I think is that right? Yeah. So. Yeah, no worries. Here to answer questions, or at least attempt to answer them. I don't know everything. Pretty far away from that. Okay, so now we need to write a shader. We're gonna have to do. Everything's already in world space. Oh my god, this is gonna be a nightmare, right? This is the bit I get confused. Everything's already in world space, so I just need the projection matrix, right, to take it to clip space, because those vertices will be issued in world space, not model space. No. I need the world space to take them. I don't need the model matrix. I need the view matrix because the camera to move them into projection space, and then I need the projection matrix to move them into clip space. Right, I still need 2 of them. I just don't need the 3rd one. I'll probably just bind the same UBO and just ignore the so the model matrix is passed as a separate uniform anyway. Let's just get the shader up. Well, I don't know why I'm guessing. I think I've got a simple vert. Here we go. So we'll change this to like line.vert. I need to view we can just keep this because that already exists and bound. And I don't need to output any of this stuff. And then I just need this sans this. Right? Could. So in position. Oh, what am I doing? Color. Out will be color. Don't need that. It will get optimized out anyway, I think, even if you don't use it. So I can't remember if OpenGL likes it. Otherwise, I'm not going to bind it anyway, am I? So that's fine. Get rid of that. Sorry, confused myself. That stays the same. This now. Color. Don't need to worry about any of this. Equals in color. Get rid of all this stuff, and then get rid of the model. Evening. I think with that, I think looks perfectly cromulent to me. The assets simple frag. The assets line.frag. Right, okay. In vec3, sorry, in color. Don't need samplers. Don't need access to the camera here. Don't need this, don't need this, don't need this. Definitely don't need all this lighting stuff. Okay. So frag color equals I think, right? One thing you found out the hard way recently is none of the classes that drop stuff on the GPU are movable. You end up having to write move constructors. Yes, there will be I don't know if you're talking about code you've copied from my stream, which is totally legit, by the way. Totally don't mind that. Or if your own implementation. But yeah, like all the buffers are non-copyable, which means you will have to move them. But if you're using if you're using something like auto release, these are movable for you. So you should be able to your default move constructor should work. Sorry, there's a question there. Oh, hang on, you're right. It's not frag color, is it? It's it is no. Oh, hang on, I'm missing the. You're right. I'm missing the out frag color. Thank you. Good spot. No, I'm. I guess a regular software engineer, if those are my two choices, as in I don't work in game dev, I just do this as a hobby, I just pretend to, for fun. Yeah, if you wrap up all those movable types you can in something like that, or a unique pointer, then you will inherit their movability, otherwise you have to write your own move constructors, which is a pain. Thanks. Got to fake it till you make it. Right, okay. Renderer. Because the renderer already has some custom material for the skybox, so I think what we should be able to do is do material debug line material, and then render it here. We do somewhere create skybox material here and post-process material, so let's do debug line material, and then cube. So this will be line. This, I mean, this absolutely should just be one function now that takes two string views. But here we are. Maybe change that later. So now after the skybox material, we can do debug line material is create debug line material and the resource loader. Okay, so now we have a material. I think we have basically everything we need to kind of piece this all together now. I think we want to do debug line material use scene. Nope. debug lines, which actually, if I've named it the same, wizard. Okay. Now we have it. So now we can do scene debug lines dot bind. GL draw arrays, and this should be GL lines. I don't know how many are in there, do I? I didn't keep. I don't think I exposed that. Can't you just draw everything in the buffer? Like, you know how big the buffer is. Can you not just assume it's full? Oh, how annoying. Not to worry. We can just expose this. Auto count const stood uint 32t. Can't imagine there'll be much more than that. Stood uint 32t count. Debug lines count will be lines dot size, and then auto debug lines count const third uint 32t return count. Right. 10 YouTube viewers who dropped off when I was talking design have come back. Welcome back. We're doing code now. It's fine. I'm not just prattling on about whether a buffer should be static or dynamic. Does this need to be after the GC clear? No, because I want to draw into. I'm still drawing into this frame buffer, right? So I don't want to clear it, especially because I want to maintain the depth information. So I'm effectively rendering into the 3D scene, and then we clear the the default frame buffer, which will be the one that gets flipped to the screen here for the post-processing. So scene dot debug lines count, and then scene dot. Actually, there's auto DBL const auto DBL equals scene dot debug lines DBL, and then just not my best name. Unbind. This uses the C++17. I can't remember what they call it. If it's not, it's if something or other. I can't remember. It's an extension to if statement which allows you to evaluate an expression here, but it only enters the if statement if this is true, and this variable will only exist within the scope of here. It basically means I'm safe to use DBL because there's no way I could get into this if statement if the optional didn't hold a value. And in addition to that, it doesn't expose DBL outside of this if statement, so it's just kind of a way of kind of encapsulating something quite nicely. I mean, it could even work. So now we need to go back to here. We do PS update, and then we do scene dot debug lines equals PS dot debug renderer dot lines, which will stick in the optional. Let's see if this builds. Then we'll do a poll. We'll do a poll to see if this is going to work. Gotta get building first. Or was that 13 or 14? 14. Ugh, fine. Okay, I'm glad you enjoy the videos, and I will keep it up. Thank you very much. Actually working on the next video at the moment. It's a bit of a weird one. It's been quite. I've laughed a couple of times at the things that have happened during it, so I'm hoping there's kind of enough there to make something entertaining. But we'll see. Okay, right. As we like to do here, we can vote on the confidence you have in me that this is going to just work first time. Let me just set up a quick poll here. Or on Twitch, you can, if you are in a country that allows it, you can gamble fake internet points. Engage with your audience, sure. Start a poll. It just work. And a prediction for the Twitch people. It could just work though. People have very little confidence in me, which is fine. I'm trying to think. I think YouTube tends to be more optimistic than Twitch. Twitch is very pessimistic. 84% no. Right. Really? Ouch. Okay, end poll. So we'll see. Okay, fine. If it crashes, it doesn't count. That's because I've done it wrong. Like, if it actually gets to the rendering part and there's lines. Oh, I mean, oh no! Is that a box? Is that just a massive box? Oh. The question is there like a sphere at the center of this? There is. Look at that. Resting on the thing. I think it worked. I'm going to call that a raging success. It's rendered a massive box, and it's put a little sphere on it. Can we see that, like, dropping? Choose outcome. Yes, it did just work first time. I'm sorry on Twitch if you lost your fake internet points, but I'm taking that as an absolute success. I didn't even have to fudge the results by by changing the code. You see, you got to have the faith. Right, okay, let's see if we can. I'd actually like to see that ball dropping. So where's the ball shape? So let's make that like 10 times bigger, and let's start it at a much higher height, like 100. I think it might drop at the origin, so literally right above our heads. I'll have to look up immediately. I might need to move myself back a little bit or move that forward. Right, okay. So I want it in the negative Z. Right? I want it to be in front of me. Let's just see if, well, let's see if, do Jolt's coordinate system aligns with our expectations. I will not be repeating that, Suncat. Might need to just alter my position a bit. Where's the camera? Game camera. What are all these? What are all these parameters? So long since I've looked at camera position. Here we go. So let's move ourselves up a bit and way back. Like, I know it's dropping. I just kind of want to see it. Do you know what I mean? We've integrated the physics engine, and I'm not actually seeing anything moving yet because we've only just seen it in the resting state. What is up with my coordinate system? That's all right. You can say what you want. I'm just not going to repeat it. I feel like something's gravely wrong here. No, I know what this is. I am rotated. Yes. I remember this. This is on my to-do list to fix. Is the way it constructs the matrix for the camera using your pitch roll. It defaults to like 90 degrees to the right or something. I'm not going to do the maths in my head. I'm just going to try all the combinations until we get it right. I've literally achieved what I wanted to achieve today, so I'm just going to literally just like faff around for a bit, and then we can have a think about what's going to happen next. I just want to just see this move. Like, why is it so? Okay, it's now behind me. I'm getting closer. This could literally be the game. Guess the coordinate system. Hello? I saw it. I saw it. Did anyone else see it just sort of unceremoniously drop down? Nice. I'm pleased with that. I'm pleased with that. Obviously, yeah, the lighting doesn't affect it, but that's fine. There's only so much. So yeah, this is why you can't see how the Imguismo is always drawn over top of all the meshes, regardless of where it is. Like, I could drop this down there and it's still rendered on top. That's because the debug layer, the debug UI, is drawn over the top of everything. Whereas otherwise, if we just done it in the same place, all these lines, under here, you'd be able to. Oh yeah, all these lines under here, like that, fancy. You'd be able to see. Yeah, it's just maths, right? We just need to maths a little bit harder for the pitch and yaw. I think it's just I can't remember. I'd have to look it up. We're going to have to add quaternions very soon, which is going to be fun because Jolt uses quaternions. So when you pull out the rotation, it is the Power Toys Z control. Because I use Power Toys to swap the caps lock and escape key on my keyboard. What is this? I mean, you'll have to be a little bit more specific. Yeah, I can't remember the specifics. We'll figure out when we get there. At the moment, the most important thing is we can literally say we have physics now. We have a physics engine, which I'm pretty pleased with. I think for what's that, 2.5 hours, integrating that into the rendering pipeline, not too bad. It's going to make our lives so much easier. What are we programming? We're going to try and program from scratch, or as much as possible from scratch, a game. So no engine. We're doing OpenGL. We're doing our own window encode, our own event code. We've just integrated a third-party physics engine because I don't actually want to write one of those, as you'll see in a second. There we go, nailed it. We got our own like debug code. We can kind of fly around. We've got a skybox. There's no game at the moment, but soon. Once the physics engine is kind of better integrated into the game and better abstracted, then we'll have all the primitives we need to actually start building something, I think. So yeah, hopefully that answers your question. And we're doing it all in modern C++ as well. Right, so it's HDR is the current texture rendering and normal mapping. I opted out, so I only want to... I'm very much torn because it's always fun writing new things and playing around with things, and it's always a good learning experience. So I was kind of torn of just like, oh yeah, we'll do PBR and we'll do like a full clustered renderer and do all these great things, when actually whatever game we're going to end up building is probably not going to be that great, not going to lie, and won't need all those fancy graphic things, least of all because I can't produce the assets for it. So we're just keeping it simple, and in my mind, only my sort of guiding principle is to only write code that gets us towards a game. So it's just a forward renderer. It's just simple point lights at the moment. It is HDR with gamma correction, but that's kind of it really, and normal mapping as well. The asset pipeline work, I think, was worth it. It took longer than I thought, but loading now is super fast because we have a. I'm happy to kind of just do a quick recap of the code if anyone's interested. Like if anyone's new here and wants to go over anything, we now have a resource packer program, which takes a directory and basically serializes all of the images and meshes in that into a format that the engine can easily understand and consume, and just writes all. It's basically a custom binary format, writes all those out, and then the game consumes that. So loading is pretty quick now, and it means packaging the game up is going to be super easy because we just package all of our resources into one binary blob. We'll probably just absolutely just cram that into the PE file, and we'll be good to go. So I'm not planning on doing more of it because it took quite a while to do, but I'm very pleased with where it is. I think it was worth it. Yeah, what's next? So what's next? Good. No one asked that, but it's still a good question if someone were to have asked it. We need to basically take all this physics code and bust it out into separate primitives. We need a shape object, and then we need a rigid body object, and then you'll basically create a shape. From that you'll construct a rigid body, and from that you'll add it to the physics system. Or what I suspect I'll do is make physics system effectively a factory for these objects, so you can only create them through the physics system. It's not. I think it's a slightly more constrained API, but it makes sense because why would you ever want to create a rigid body object and not add that to the physics system? So we can kind of avoid a lot of the potential pitfalls of I've created a rigid body, but I've forgotten to add it to the physics system, by just saying physics system, hey, creating a rigid body, and getting back some sort of handle or some sort of reduced object which just exposes specific functionality we need, like get me the position or apply an impulse or something like that. How did you resolve the ownership of the read file into memory and representing it as usable data to the rest of the game? I'm not quite sure I understand, but it's basically all encoded as a TLV. So these are the types you can serialize. You can do a uint32 and a uint32 array, a string, a byte array, text format, text usage, vertex data or vertex data array, or aggregate types like a texture, description, or mesh data, which is just a combination of these. And then you just pull them out. Basically, you get this TLV entry, which TLV reader is an iterator for the reader. So you give the reader a big binary blob, and then you can just basically do for each. You can do a range-based for loop over it and pull out each of these individual entries and query what the type is and get it out as that. which is really nice. I think the code came out really nice. If you look at the tests, because yes, we even have some tests. They're not great. I would like more tests. There's a good one. There you go. Yeah. So you serialize your type length value. What that's doing there? Get rid of that. What is going on? It's a number and a string, and then you can literally just loop through each entry and pull it out as an int or a string. This is not a great test, as in like you wouldn't write code like this, but it's kind of good to get an idea of it. And then you got the writer as well. So I don't know, works quite nicely. So a great question is, would TLV benefit from compression? Depends what you're storing in. TLV would 100% benefit from compression because we have effectively decompressed all the data. We've taken a ping, or JPEG, which is a compressed format, and we've just serialized all the RGB triplets straight into memory. So it is massively bigger than the original file. We don't need it now. So again, part of my kind of guiding principle of only writing code that we need, that gets us towards a game. We don't have, it's not compressed. What I think we'd probably end up doing is having something like a compressed byte array, which inherently would produce, which would, when you grabbed it as a value, would decompress it. So the length would be the length of the compressed data, but it would return you probably a copy of the bytes uncompressed, and then that itself could be a TLV. So you could serialize all your data as a TLV, and then stick that in another TLV as the compressed option, and then put it out. That's kind of where I'm thinking with that. So yeah, you just grab off the shelf any compression library that you want. Yeah, it will do. We've just not got there yet. I think for release, that I foresee several streams where we get stuff ready for like a release when we've actually got something we want to kind of build. So like stripping out logging, doing release builds, removing like the debug line stuff, or making sure it's not there, compressing the resources properly, using CPAC to properly package everything up. Like I foresee work to be done then. So that's kind of my plan, is to solve those problems when we actually get around to it. I think solving them now, I think there's little value in it now, because I don't know how it's all going to change by the time we get there. And it seems like effort that we better spent in actually driving us towards like something playable. Again, it's just gonna be, it's probably just gonna be a simple game. It's not gonna be massive. It's gonna be something that I can do myself. It's not gonna require a lot of assets. It could even be something like a Flappy Bird clone or something like that. Just to showcase how to build a game. I'd like it to be something a little bit more novel than that. But do you know what I mean? This is all about, can we build something from scratch, package it up, and get it on itch.io or something like that. And then the next project, I'm sure, will be a more complex game. I would love. I'd love to do an FPS, but I think that's just a huge amount of work. I think I need to learn a lot more about all this first, and this is my way of learning it all. I think once we've kind of gone through all this and learned some lessons, I'd love to try and make an FPS, but way like, I mean, it's like sort of 2026 maybe. Oh, I see. Sorry, you're talking about the mmap file. So we had an issue where, due to my unique dev environment, reading files was incredibly slow, which is one of the reasons why we wanted to serialize it all into binary data. But we ended up writing this. So this is a file abstraction. So you give it a path. And how you want to open it, and then it just uses the raw Win32 API to open it and then memory map it. And what memory mapping does is gets the kernel to map the file contents into memory for you, and then you basically just get back a pointer that you can read and write to, and then I just return it as a string or as a data, and these are just spans over the raw data typed to either char star, const char star, or const std byte star. So yeah, all this class does is manage the Windows handles to the mapped memory. It doesn't own the actual file data; those just exist in your process memory space now, and then this just allows you to kind of interact with it. How much does decompression cost? I mean, it'll be very compared to, I suspect, very almost negligible compared to all the OpenGL setup you have to do, like copying all the model data over to the GPU, initializing all the levels. Like, I suspect the decompression is almost nothing, especially if you pick because decompression algorithm, there's loads of decompression algorithms, and they will have different trade-offs, and some of them favor like fast decompression over slower compression, and vice versa. So you could just pick one that is maybe like slower to compress because you're going to do that offline, and then faster to decompress. But on a release build using SIMD instructions, I expect it to be like almost nothing, like negligible, especially for like the amount of data we're going to be doing. If you think like, how long does it take for you to open a ping file? Like if you double click it and open it, that's got to do some decompression and then get it to your graphics buffer. You know, get it to your frame buffer. If you've got even a couple of hundred pings and JPEGs, I really don't think it's gonna be a lot. But it's a good question, and it's worth checking. Oh, hang on a minute. I'm not even on my fancy chatting screen. What am I doing? I suppose I have been showing code. Okay, I'm going to think about wrapping up there. Thank you, everyone, for coming along. It's been a good stream. I'm glad we kind of got something achieved. I've got at least enough for a YouTube community post, which is really the main thing about it. You know, it's kind of the asset pipeline was great, but it wasn't really a lot I could kind of demonstrate. So at least I can put up a screenshot of the sphere. Yeah, next Sunday we shall. Next Sunday we shall continue this. We will start building out better abstraction, and I think from there we'll be pretty close to. It will be dangerously close to actually making a game, which is kind of terrifying because I'm gonna have to think about something. I'm gonna actually have to think of a game to make. All this is just an excuse to put off making a game because I quite enjoy this bit. But anyway, I hope everyone enjoyed themselves, and I'll catch you in the next one. Thanks so much.